Hey everyone, welcome back to Learn a Level, and in today's video we're going to look at an alternative way of thinking about polynomial long division. Without any further ado, let's jump straight into it. So the aim of the game is a lot like when we divide integers by other integers. Let's say I want to divide 15 by the number 6. I might notice that 6 goes into 15 twice with a remainder of 3. So when I say that 15 divided by 6 is 2 with a remainder of 3, what that really means is that the number 15 is the same thing as 6 times 2 plus 3, which it is, because 6 times 2 is 12. What we want to do is this, but with polynomials. So given a polynomial p of x and a factor f of x, so I want to divide this polynomial by some factor f of x, I want to be able to write p of x as the factor f of x times another polynomial, the quotient, so we'll call it q of x, and it may also have some remainder, so plus r of x. So here, p, f, q, and r are all polynomials. And the reason I want to be able to write p of x in this way is that if I was to divide p of x by this factor f of x, I would know that this is the same thing as q of x plus r of x divided by f of x. So in this way, I've changed this rational function, so a division of a polynomial divided by another polynomial, into a regular polynomial, and then another, I should close that bracket, and then another rational function. So we've isolated what part of the function is being divided by a polynomial. And this can be very helpful when we want to analyze certain things about the behavior of this function. So with that out of the way, let's jump straight into 5 different examples so we can get the technique down. Our first example is to factor x plus 3 from x squared plus 5x plus 6. So the way I'm going to do this, and I'm going to approach every example the same way. I know what I want to factor, and I know what I'm factoring it from. So the way I'm going to do it is I'm going to write out the factor I want, x plus 3, and then I'm going to open brackets, and the game I'm going to play is all about matching terms. So we want to match terms. So here, what I want is I want an x squared, and the only way I can get an x squared from this is if I multiply x by x. So x times x will give me x squared. But by introducing this x in the next bracket, I've also introduced plus 3x. And I don't want plus 3x, what I want is plus 5x. So in order to get that other plus 2x that I'm currently still missing, I'm going to add a 2, which then when multiplied with this x will give me plus 2x. But by introducing this 2, I have also introduced plus 3 times 2, so that's plus 6. And I actually do want a plus 6 in my polynomial. I can leave that and we're actually done. So there we go. We found that x squared plus 5x plus 6 is equal to x plus 3 times x plus 2. Let's have a look at another example where we'll actually have a remainder this time. So we want to factor x minus 8 from x squared minus 7x minus 13. So I'm going to do the same thing as before. I'm going to write what I want factored out and open a bracket, and now I'm going to play my term matching game. I'm going to figure out what terms go in the brackets based off what I want. So I want an x squared. The only way I can get this x squared is x times another x. But by introducing this x, I've also conjured up a minus 8x. And I don't want a minus 8x. What I want is minus 7x. So in order to correct this, I'm going to have to introduce plus 1x. I've got minus 8x, I want minus 7, so I need a plus 1x, which I'll get from there. But in doing this, I've also introduced minus 8 times 1, so minus 8. And I don't want a minus 8, but I can't go any further in this bracket. I've got x plus 1. I can't introduce some amount of x to the minus 1 or 1 over x. It will complicate things. So I have to stop here, but I don't have what I want. So I need to correct it. I have a minus 8, but I want a minus 13. The one way to figure out what this remainder ought to be is let's get rid of that minus 8 I don't want, plus 8, and let's introduce that minus 13 I do want. So this polynomial I've written should be the same as what I started with. So we find this plus 8 minus 13, that's the same thing as minus 5. So x minus 8 times x plus 1 minus 5 should be the same thing as x squared minus 7x minus 13. Now, if you need to prepare polynomial long division for an upcoming test or an exam, this next bit will be really helpful. We have this answer, we should check it, and we can check it very easily by expanding. So let's expand this just to make sure we've got it right. This will be x squared, that's that one, minus 8x plus x, so that's minus 8x plus x, and then minus 8, and then we've also got minus 5. And that is equal to x squared minus 8x plus x is minus 7x, minus 8 minus 5 is minus 13, and that is indeed equal to what I started with. So it passed my check. If you're getting ready for an exam, definitely also practice your checking mechanisms to check whether the answer you got was correct. Awesome, let's look at another example. Let's factor x plus 3 from 3x cubed plus 6x squared plus x minus 4. So again, I'm going to play the exact same game. I know I want to factor out x plus 3, so let's write that, and then I'll open my brackets and I'll start playing my game. This time I want 3x cubed. The only way I could get 3x cubed is x times 3x squared. That's the only way I can get that term. But in introducing this 3x squared, I've also introduced plus 9x squared. I don't want plus 9x squared. What I want is plus 6x squared. So in order to correct what I have, I'm going to have to subtract minus 3x. Because then when I multiply that by this x, I'll get plus 9x squared minus 3x squared. That'll give me my plus 6x squared that I actually want. But of course, I've introduced a new term. I have also introduced minus 9x. And I don't want minus 9x. What I want is plus x. So I have to look, how am I going to correct this? The only way I can correct it is I need plus 10x. So I'll get that x times plus 10. That way, that will correct that last term. However, I have introduced, as well as this, a plus 30. I don't want plus 30, I want minus 4. I'm going to need to close this bracket and correct that. I need to subtract that 30, I don't want that plus 30, and introduce that minus 4 that I do want. So what we find after playing this term matching game is that 3x cubed plus 6x squared plus x minus 4 can also be written as x plus 3 times 3x squared minus 3x plus 10 minus 34. And again, if I was getting ready for an upcoming test or exam, I would want to practice, as well as the technique, checking my answer. So let's check this just by expanding it. First, I'm going to expand these terms. So I get 3x cubed minus 3x squared plus 10x. So that's this x times these three terms. Now I'm also going to multiply by this, so I'll get a plus 9x squared minus 9x plus 30. And then I also have this minus 34. That is equal to 3x cubed. That's that one. And then plus 9x squared minus 3x squared is plus 6x squared. And then minus 9x plus 10x, that's plus x. And then plus 30 minus 34, that's minus 4. And this polynomial is indeed the one I started with. So my check worked, I got it right, I can comfortably move on. Alright, let's look at some polynomial division now. So we have a polynomial divided by another polynomial, and we want to rewrite it in another form. So the way we're going to do this is by playing the exact same game as before. First, I want to note that 2x squared plus 5x minus 9 can be written as x minus 3 outside of, and now I play my game. I want 2x squared. The only way I can get that is x times 2x. There we go, I've got my 2x squared. But I've also introduced minus 6x. I don't want minus 6x. What I want is plus 5x. So how am I going to correct this? Well, I need to introduce plus 11x so that I get rid of that minus 6x and still get the plus 5x that I do want. So I want plus 11. So I get my plus 11x that way. However, I have also introduced here minus 33. And I don't want minus 33. What I want is minus 9. So I'm going to have to close this bracket here and then add 33 because I don't want that negative 33. And then I'll subtract my 9. Cool. And then I might note here that 33 minus 9, that's the same thing as 33 minus 10 plus 1. That'll be plus 24. So 2x squared plus 5x minus 9 can be written as x minus 3 times 2x plus 11 plus 24. So I know that 2x squared plus 5x minus 9 over x minus 3 is the same thing as x minus 3 times 2x plus 11 plus 24 over x minus 3. And here I can split up this first term and this second term so that I get to cancel those x minus 3's. And that way I get 2x plus 11 plus 24 over x minus 3. And that is my answer. Again, we could double check this step here. This is really the crucial step, rewriting that polynomial as a factor, quotient, and remainder. I could double check that by expanding my right-hand side. Awesome. Let's look at our last example. Rewrite that cubic over 2x plus 5 as a quotient and a remainder. So let's have a go. The first thing I want to do is I want to note that 4x cubed minus 4x squared plus x minus 1 can be written as 2x plus 5 outside of, and now I play my game. I want a 4x cubed. I can get this by multiplying 2x by what? Here it's going to be slightly different because I'm multiplying by 2x, not just x. So it'll be 2x times 2x squared. That's going to give me my 4x cubed. But I've also introduced plus 10x squared, and I don't want plus 10x squared. What I want is minus 4x squared. So what do I need? What I need is minus 14x squared. How am I going to get this? Well, I have to be very careful. I don't want to introduce minus 14x. I don't want to do that because it's not going to be multiplied by x, it's going to be multiplied by 2x. So what I really want here, it's not minus 14x, but minus 7x. Because that way, when it multiplies with 2x, it will give me minus 14x. However, by introducing minus 7x, I have also introduced minus 35x. And I don't want minus 35x, what I want is plus x. So in order to get the plus x I want, what I need is plus 36x. What do I need to multiply with 2x to get 36x? What I want is plus 18. 18 times 2 is 36. So there we go, I'll close my bracket, but I'm not necessarily done because what I've also done is introduced 5 times 18, which is the same as 10 times 18 divided by 2. So I've introduced plus 90, and I don't want plus 90, I want minus 1. So I'm going to need a remainder here of minus 91. So that was a bit more of a hectic example, but what I hope you notice is that it's the exact same game as before. At least now, it turns polynomial long division not into a difficult problem, but into potentially a tedious problem. It's no longer difficult, we do the same thing every time, it doesn't change. It just might be more tedious if the numbers aren't quite as nice or if the polynomial is longer. Okay, but I've got my expansion, I've got my factorization of the polynomial, so I can write this. I can write that 4x cubed minus 4x squared plus x minus 1 over 2x plus 5 can be written like this. 2x plus 5 outside of 2x squared minus 7x plus 18 minus 91 all divided by 2x plus 5. And then again, I can split up that numerator so that I can cancel the 2x plus 5. So I've got that this is the same thing as 2x squared minus 7x plus 18 minus 91 over 2x plus 5. And again, this step here, where we factorize the polynomial, is definitely the crucial step. So it'd be worth double checking that by expanding the right-hand side. And I encourage you to give that a go. All right, but here we go. We've got our polynomial division written in the way we were asked to write it. Excellent. I hope you found that helpful and perhaps a preferable way of thinking about long division. The thing I really want to stress here is that what we're doing is basically the same thing as long division. It's just writing it in a bit of a different way. So instead of memorizing the formula, write this number here, carry it up here, write this here, which can be very detailed and a lot of information to memorize. Instead, we frame it as a game. We just want to write the factor we know we want and then fill in the blanks at every other step. And if you need to write on the side a few smaller additions, subtractions, multiplications in order to figure those terms out, that's totally fine. But writing it out as this game can often give us the kind of direction that is a bit obscured in the long division algorithm. Awesome. I also want to point out that this technique of matching terms is very general and works for a lot of other types of questions as well. Even in the realm of long division, we could have gotten more complicated examples, such as dividing a quartic by a quadratic. So we only went up to cubics and we only divided by polynomials of order 1. We only divided by linear functions. But we can totally play the same game with more complicated polynomials in the denominator. And it'd be the same. So let's have a go at this one just to see how it pans out. I know that I want to factorize out x squared plus x plus 1. And if I start by playing my game, what do I need to get that highest order term, that x to the power of 4? I need an x squared. But then we also conjure up an x cubed and an x squared, which are both terms we want. All we have left is x and 1, and we can't get that by multiplying x squared by a non-negative power of x. So we actually have to stop the factorization there, and we have a remainder of plus x plus 1. But the game still worked. It was a weirder example because we were dividing by a quadratic, and a quadratic that looks a lot like our numerator, but it's the same game. So what I could do is I could write this quartic which is divided by a quadratic, in just the same way as before, it'd be x squared plus x plus 1 over x squared plus x plus 1. So I hope you found that helpful. I hope you had a go at some of the questions, followed along on with some pen and paper, and hopefully you enjoyed it. I know polynomial long division can be quite an intense algorithm to just remember. So I find that framing it like this game, almost a bit like Sudoku, I just want the term that matches, I want the term that fits in. At the moment, I find playing that game an easier way of going about polynomial long division than memorizing brute force algorithms. So hopefully you like that. If you did, let us know. Like, subscribe, leave us a comment, whatever you want to do, and I'll see you in the next video. Thanks.